Hello again everyone, welcome back to ptet.chemistry channel. So in this new series of tutorial videos on multiple choice questions, this category 10.2 is my categorizations for the hydrocarbon topic, which include alkane and alkenes. So that include all those free radical substitution reaction of alkanes, as well as the electrophilic addition we usually associate with alkenes. So in this first question, it's just basically asking you on the type of reaction. So these kind of questions, since they give us the formula, I always like drawing out what is going on in terms of skeletal formula, because it's nice and straightforward, and it's good practice for my skeletal formula skill as well, because the more I use it, the easier I'll find it when the time comes, okay, because you really need to master your skeletal formula if you really want to do well in your A-level chemistry, plus it's enjoyable as well. You keep on counting the carbon from 4 bonds, all right? So there's a hydrogen which we don't show bonded to that carbon there, there's a hydrogen which we don't show bonded to the carbon there, okay? So they're asking in stage 2 what happens. So you see how the CF3 and the CF3, okay, they remain the same. But what has happened in stage 2, which is from here to here, this is stage 2. I hope you can see there's a hydrogen. Yeah, it's not a very good skeletal formula because we don't show it, okay, but I'm showing it because I just want you to see what has gone on. Maybe I should use a different color. Okay, so there's a CH there. There are actually 2 of the CH. Now there's only 1 of the CH because one of them has gone to CBr. So this is a free radical substitution. I hope you know you need a UV light and a source of bromine. So this is your initiation. So your UV light would give you your free radical like that, okay? But of course, the free radical can react with one of these, which sometimes they ask you in theory, what will happen if you react one of those. So if you have CF3, CH2Cl, you could react with a Br dot. What will happen with the Br dot is it will take out one of the H, and then it will form HBr, and then you'll be left with CF3 CHCl. Because you take away one of the H from the carbon, now the radical is on the carbon instead of on the bromine. You form HBr. This is a propagation. They like to ask you in theory. So show in a series of equations how you get that in a propagation step. Propagation means from a radical forming another radical. But how can you get the product in the propagation step? So that one can react with more of your bromine molecule, and then you will take away a bromine. So the C dot take away a bromine, and now you have another bromine radical. Guess what this can do? This can do more of that, all right? It's a chain reaction. So free radical reaction is what I call a chain reaction. Another interesting thing is, if this is a theory paper, they can ask you using a termination step, or show, in the case of termination, the formation of the product. So if you want to show the formation of the product in termination, then you will need a radical plus radical give you the product. You see the difference between propagation and termination in forming the product? When you have propagation in forming the product, you have radical on the left and radical on the right. When you form the product by termination, it's simply radical recombination without forming any more radical. Okay, of course it's a very straightforward question. I'm just thinking that they could ask you to do free radical substitution for any reaction, not just the standard case study or mid-10 that you do in textbook. They can ask you with any example in reality. Okay, so next bit is about incomplete combustion of a hydrocarbon fuel. So we're talking about pollutants. So incomplete combustion of a hydrocarbon, you see, compound containing carbon and hydrogen atoms only. Okay, so there has to be a CO, all right? So in this question 3 is actually quite a bit tricky actually, because it's talking about exhaust fumes. It's not talking about inside the car engine. So we know the N2 plus the O2 giving you 2NO. So that happens in the car engine. where the combustion happens. So there's very high temperature in the car engine where it happens. Exhaust fume is where after all those reactions that happen, after the catalytic converter step, okay? So after you pass it through the catalytic converter, what goes out? What goes out from the exhaust fumes? So in terms of carbon monoxide, we can really not think about it because most of the carbon monoxide will have been converted into the cleaner CO2. But what is important is that is exposed to air. And we're talking about greater amount. That is exposed to air, and in air alone you have 78% nitrogen plus around 20% oxygen. So these are from your O-level constituent of air. Because the exhaust fume are exposed to air anyway, so you will have a lot of nitrogen in there, okay? Well, exposed to the air in the exhaust fume. Because there's a huge constituent of air, and also because the nitrogen won't have reacted in the exhaust fume because it's not hot enough, unlike in the car engine, is where the gases come out. Alright, so this is quite tricky in that sense. So in this question 4, it's basically about the number of carbon atoms in the alkane and the moles of oxygen gas needed for the complete combustion of alkane. Alright, so this is about alkane, this is about complete combustion of alkane. So what we can do is we can write a general equation. So we know CXHY plus O2 hydrocarbon give you CO2 plus H2O. If we have 1 mole of this, X mole of carbon will give you X mole of carbon because there's no carbon there, okay? There's no hydrogen there, so Y mole of hydrogen, you would need Y mole of hydrogen atom. You cannot have Y there because you will get 2Y mole of hydrogen atom, whereas you only have Y hydrogen atom here. Therefore, I need to Y over 2 because Y over 2 times 2 will give me Y, number of hydrogen atoms on the right, which is the same as on the left, okay? When I do all that, how many atoms of oxygen do I have? I will have 2x, I will have Y over 2 oxygen atoms. So what I do is, that goes there, I will have 2x plus Y over 2 oxygen atoms, okay? But I have a molecule, so what do? I need to divide by 2. So when I have 2x, when I have 2x plus y over 2 divided by 2, it becomes 2x over 2 plus y over 2 divided by 1 over 2. And that will give me x plus y over 4. So that give me x plus y over 4. So in reality, you might have learned this equation by heart, but do you actually know how to do the algebra just by thinking about balancing equation? Alright, so you might or might not have seen this equation, but that is how we're going to get the number of carbon atoms in alkane increases, there's x, and the number of moles of oxygen gas is going to be x plus y over 4. Alright, so first of all, we know it's not going to be constant because it's not going to be constant. Alright, the other thing is, will it be increasing in a constant gradient? Okay, so well, we can put in some examples, I guess, if you want to. So we can try I don't want to rub that out, so maybe I can try that. So CH4 plus 1 plus 4 over 4, that's 2O2. Give me CO2 plus 2H2O. You can try C2H6. So there's 2 plus 6 over 4. So there's 2 plus 1.5. So there's 3.5 O2. It's 2 CO2 plus 3 H2O. I'll start with the next one really. C3H8. Okay, so 3 plus 8 over 4, that's 3 plus 2, that's 5 O2. 3 CO2 plus 4 H2O. Okay, so I've done enough in such a way that you can see plus 1 carbon, plus 1 carbon. Here you have plus 1.5 O2. Here you have plus 1.5 O2. So do you see how it is a fixed number of mole of oxygen for each increase in carbon? Okay, so it has to be a fixed increase. Okay, it's a linear increase. We are looking at a linear increase. Okay, and not a curve, and definitely not this, because this means no change at all. And we definitely know we need more oxygen gas. We need more oxygen gas as we have more and more carbon, but it does not increase by more than whatever it was before. It's a constant increase in the mole of oxygen required for every single increase in carbon. All right, so it has to be a linear relationship. All right. So this is the last question of this short tutorial series on 10.2, section 10.2, which is on hydrocarbon, alkanes and alkenes chemistry. So this is P. I'll convert it to skeletal formula because I find it easier to work in skeletal formula. So this is CH3, CH2, CH. So they don't tell me whether it's cis or trans. I'll just draw this first because it does not matter anyway. CH2, CH2, OH. Read carefully. CH3, CH2, CH, double bond, CH, CH2, CH2, OH. Okay, when you draw skeletal, always check that you haven't miscounted a carbon or something, alright? And obviously there's 1, 2, 3, 4, 5, 6. You can see it's 1O. That means it's position 1 for the important alcohol. It's position 3, not 4 for the alkene, hex 3 in, alright? So now you have hot, concentrated, acidified KMnO4. Without the acid, your redox will not work. You can think back about your redox reaction ever since O-level. Have you ever seen MnO4 minus without the acidified? Okay, that's because you need the acidified MnO4 minus. Okay, otherwise it will not work. If you forget the acid in your condition, it will not do this reaction. All right. So this is hot, concentrated, acidified MnO4 minus. This will do the extreme oxidation of carbon-carbon double bond. You will rupture or you will cleave carbon-carbon double bond. Okay, so you will cleave that, but do not forget that you have a primary alcohol here, because the carbon bonded to the OH is bonded to one other carbon. The carbon with the OH is bonded to one other carbon. Primary alcohol can also be oxidized. This is manganese plus 7. I hope you can do oxidation state. In case you can't, you need to look back at your redox chemistry and think that this is also known as potassium manganate bracket VII, because it's manganese plus 7. Alright, you can work out the oxidation step from there as well. So that's going to be oxidized all the way to carboxylic acid. Okay, so there's the one key mistake that a lot of students will miss out, because they did not think that, oh, only that reaction, they forgot about this, or they remember this but they forget about this. All right, so very important that you do not forget it. So when you cleave alkene under these extreme conditions, you can have 3 different cleavage. CH2 double bond will cleave to CO2. When you have what's the other one? Oh, I forgot about this. When you have COOH, that will also give you CO2 as well. Yeah, so just bear in mind. Okay, so there's an ethane dioic acid. So that's case number 1. Case number 2 is RCH double bond. You will get RCO2H, carboxylic acid. And the third case is when you have like that will give you a ketone. Alright, so when you have that with 1 hydrogen, you get carboxylic acid. This is a RCH. This is also RCH. So this is a RCH. This is also RCH. So what you will get is, you will get a carboxylic acid. You will get a carboxylic acid. And then this end will also become a carboxylic acid. So that's that. I hope you can see there's 1, 2, 3. I should label it 1, but I'm just showing you that those are the original carbon that have been cleaved out. The primary alcohol has become carboxylic acid. This is RCH, it has a H there, become carboxylic acid. There's a H there, RCH double bond, carboxylic acid. Alright. So looking at the formula given, this is still one molecule, so it can't be that. To get the diol, those two are the diol onto carbon-carbon double bond, you need dilute. Well, you can use acidified MnO4-, but it has to be col and dilute. Here, you still have the carbon-carbon double bond and you have hot and concentrated condition, so it can't be. You don't get aldehyde because when you do oxidative cleavage of carbon-carbon double bond, they rupture totally. Okay, they either give you ketone, carboxylic acid, or carbon dioxide. Never aldehyde. Okay, so it has to be D by elimination, but in theory they love to ask you to throw it out. So be able to write down CH3, CH2, CO2H, HO2C, CH2, CO2H. This is the proper way of writing the structural formula. Okay, so this is the end of this 5-question series on hydrocarbon chemistry. So I'll see you in the next video. So please subscribe to the channel if you haven't, and share with your friends and relatives and colleagues. Alright, I hope it helps. Thank you for watching.